Hello everyone, welcome back. This is Weibo Zhao and Sami Chong from AWS Community Builders. And this is our third session. We will talk about the Kubernetes analogy as we have mentioned last time. And yeah, so here we are.
Nice. Ice cream. I just know today we're going to talk about ice creams.
Yes, that's good point. And let's start our topic of today.
Mhm.
So, well, we'll start from what is vanilla Kubernetes? Have you heard about this concept, Sami?
I know what a vanilla is, the most popular and basically is the how does it the basic one, basically plain. That's why they call it plain old vanilla. So what's the plain old vanilla Kubernetes mean?
And actually, it means that it is a very original version of Kubernetes, and it only has the basic component that inside, but no more than that. For example, some functionalities like the ingress, managed load balancer, auto scaling, CI/CD, logging, monitoring, all of these
Mhm.
functionalities it does not contain, are not inside of that. It only has some basic
Mhm.
component like what we have showed you last time about this Kubernetes cluster. We have the control plane and data plane, and also the different components that live inside. And this is actually called the vanilla Kubernetes cluster.
Got it. So, but don't confuse vanilla means it's incomplete. Just like when you're having vanilla ice cream, you will be satisfied, but just not fancy.
Yes, exactly. So on the other side, we also have a managed Kubernetes, and so you can see that this ice cream is much more fancy. And usually, these managed Kubernetes are provided by the cloud providers like AWS, Google, and Azure. And AWS has the EKS, and in this case, the total control plane will be managed by AWS EKS itself. And what we only need to do is just deploy applications inside.
Nice. Like in this picture, you can see this is not plain old vanilla. This become a sundae. You have so many different flavor. Of course, cost you more. So sometimes you have to think, do you need more? But let's continue.
Yes, that's exactly when we have added so many different components. Actually, it means that in the managed Kubernetes, the cloud providers are adding more functionalities in our Kubernetes. And here we can see that there are several types of Kubernetes. And for example, we can do it in a managed way, and which is also the easiest way. And also we can do it in the custom edge, like in your own PC, to build up the Kubernetes clusters on the virtual machines. And also we can do it in between. And there are several options like like Rancher, Tanzu, and in this case we can build up the hybrid, which combines the cloud and on-premise technology together. So yes,
Hmm.
these are the three ways.
Nice. I like this picture. Basically, you can choose how much work you want to work on. The further right, lots of work. The further left, not much work, then you pay more. But again, it's a business. Like I give you a good example. If your business has to be support cloud and also on premises, it may be easier to using Rancher as your orchestration tools. But again, cloud provider have some options. Sometimes you can actually do it on your hybrid on premise. So do not think you have to pick one. Sometimes you can mix and match.
Yes, that's exactly the truth. And by using, for example, managed Kubernetes, and we can do many things easier, like the version upgrade of Kubernetes.
Mm-hmm.
The next topic, we would like to talk about the relationship between the service and the pod. And Sami, you see this picture. What do you think that we will talk about here?
You say shepherd and the sheep, they like to eat grass. At the end of the day, we can slaughter those sheep and get lamb chop. Yummy.
Yeah, actually, here I want to explain a concept that when we want to reach the applications that deployed inside our container that live in the pod, and usually we do not find these pod IP addresses, but the service virtual IP, and it is something like the shepherd and sheep. So usually when we are a manager of this one company, and we raise a lot of sheep, and usually we will talk with the shepherd and let him to kind of take care of the sheep, and we talk to the shepherd. We talk not directly to the sheep.
Correct. And each shepherd going to own, or they are responsible for a group of sheep. They don't have to know. They don't have to do more than what they have to responsible for.
Yes. The shepherd is responsible for finding the sheep, and this is exactly like the service are using the label selectors to find the pod, and which is exactly what we duplicate here. And each pod will have its own IP addresses, and which will be also showed in their endpoints. And the service can use the selectors, which is the same as the labels that the pod has, and then so that the service can find out the pod and direct the traffic to the pod. And also these pods can be managed by deployment. In the production environment, we do not create the isolated or separate pods. The pods should be always managed by, for example, deployment, daemon set, stateful set, and also other things like jobs and so on.
Yes, and I see also you have a label. Like go back to the previous example, it's like each shepherd, they have a group of sheep. Each sheep have a label, so they're responsible for communicate or take care of those sheep have that label.
Yes, that's exactly the truth. For example, we have more shepherds in our company, and in this case, each shepherd need to find his own sheep, and then we are using the labels to identify that. And the next analogy we would like to share about is this kind of Kuba park. Can you explain this, Sami?
Yeah, it's kind of like you go to the park. If you pay for some service or like a ticket, you can only go to play the ride on certain color. Like the red one, you can only go the merry-go-round. But if you want to do like the roller coaster, you need to buy a ticket for the green one.
Yes, exactly. And actually, the different colors represent the different labels. That means that because of these labels, then the different traffic, they can reach to different services and also reach to the corresponding pods. And that is the meaning of the different color. And what else is that we have the something you can see that inside of one pod. What do you call that here?
Oh, merry-go-round. Just go around, you're happy, so happy, just keep doing it and doing it.
And you can see that there are also multiple containers inside of that pod. That means that there are also multiple play stuffs inside of this this pod. And we also have a very big gate, which is the ingress, which that means all the traffic will get into our Kuber Park, which are our clusters, through this ingress. Okay, and the next thing that we would like to talk about is the difference between the declarative and imperative. And do you know
I do like these two pictures. Is most of the time we can solve the problem by, hey, wait about, I want to go home, go turn right, and then go straight for 2 miles, and go turn left, and then go turn right. Or I just say, hey, wait about, you are the taxi driver, take me home. This is my address.
Exactly. So if you use the declarative way, you just describe the end goal. And we do not care about how these kind of cars where did they go, but we just usually it will find the like for example, if this is an AI driven car, it will just find the optimal path to take me home. And this analogy is something like what we do with the kubectl tool or Kuber control tool. Usually we can create the Kubernetes object with the YAML file, which is declarative. And this is also very recommended in the production environment to write everything with the YAML file. And so this is infrastructure as code. And also we sometimes we also use the imperative. For example, in the certified Kubernetes administration exam, it is very recommended to use the imperative because it's really fast and very efficient and very useful when you do the troubleshooting work. Okay.
Yeah. One thing I do like go back to the example, the vehicle one. You can ask the vehicle to go home. You can manually override. For example, there's some accident or like the road has under construction, the computer doesn't know what to do. So you can always override and then give them imperative instruction. But the way how most people work or how the business want to look at it is I want to hit the aim. The aim game is going to go home. But sometimes being an administrator, you cannot say, I do not know how to do those like CLI, those are command line, then you are not an administrator. But as an end user, declarative is the best, but I just need to go to my destination.
Exactly. The last thing that we would like to share is about the sidecar. And you might, when you learn about Kubernetes, you heard about the sidecar, and sometimes you might be confused of why it is called sidecar. Actually, I want to use this picture to show you that this is actually the sidecar, and in this case, we have a motor driver and also someone who will sit beside into this sidecar, and actually there are two persons, and they have different roles. For example, the drivers will drive the motor, and the person who sits in this seat can just, for example, do some extra work like finding the correct direction and finding the right path and do some supporting work for these drivers. And actually in Kubernetes, we also do the same thing.
Yes, just think this way, the motors are the rider doesn't need the sidecar to go to that destination. But the sidecar can be the person read the map or doing communication, and when you are riding the motorbike, you do not want to get distracted. Also, the sidecar itself go nowhere. You need to have a motorbike. So it's work together for better. So like in Kubernetes, for example, you maybe have some container need to do the security. It's more secure. You have a sidecar to do all the security or add extra processing. So this way, if someone wants to penetrate your Kubernetes the container. The container have a sidecar, so that way the pod is more secure, and that's one use case.
Yeah, here I would like to specify. Actually, it's not the container has a sidecar, but the pod has sidecar, which means that inside of one pod we have multiple containers, and one container might be the main container, main application containers, and some other containers are the sidecars that support it. Like an example of the sidecar is when we do the ES2, for example. Without the ES2, every pod will need to, when they communicate with each other, we need to write this communication logic inside of our applications. But after we use the ES2 will inject a sidecar container into each pod, and these sidecar containers are used to communicate with each other, and then we can achieve this kind of decouple this main application with the sidecar, and so that we can make our applications more focused on our business logic.
Yes, nice. And another use case is like maybe do the logging. The sidecar is do all the logging. So again, don't overuse it, but basically the better way you can isolate the workload, the better, and also for upgrade to maintenance to debug. So yeah, that's the good use of a sidecar.
That's a good point. The logging, why it can achieve the logging? Because the sidecar and application containers share the same volumes, and also the sidecar can do the other works like monitoring, and this is also a use cases of sidecar. Okay, that will be the end of our session. As the last point, I would like to recommend a project called the Community Cloud Native Ambassador or CNCF Ambassador, where you can also, it is kind of like the AWS community builder, and but it is based on the CNCF. And if you like, you can also apply for that. And they have the application open just in 2 times for 1 year, and you can just apply it next month in July.
Yes, AWS community. Do not just watch the video, be part of the community and contribute. You will be amazed how much you can learn, how much you can contribute.
Okay, so thanks a lot for your attention. If you like this video, please press thumbs up, and also leave your comments in below. And we will see each other in the next video.
All right. Bye, guys.
Bye.